Hey, and welcome back to Hands-on Problem Solving with Machine Learning. In this chapter, we're going to go through a process called data wrangling. Specifically, in this video, we're going to talk about types of messy data and how to clean them. Let's dive right in. So I'm in my Jupyter Notebook again, and we have installed the system in the first section of this course. And so if you navigate to the code files, the accompanying code files that come with this course, and in your terminal start the Jupyter Notebook instance as I've showed you earlier, you will see a list of notebooks titled Chapter 1 to Chapter 6. So obviously we're in the Chapter 2 of the notebook, and in this topic we're going to talk a little bit about data wrangling. So what is data wrangling? To go from a problem to a solution, you usually get some real-world data from your team, and it usually looks nothing like the toy data sets you see in tutorials. So the process of getting raw data into a form of data that is clean and usable by machine learning algorithms is collectively called data cleaning or data wrangling. There are two key tools to solving issues with data cleanliness or quality. The first one being pandas, and the second being NumPy. So in N8, what we're doing here is we're first importing pandas as PD, and importing NumPy as NP. Now you might wonder why that is the case. Why are we importing something and giving it an alias? The reason is very simple. Typing out pandas or NumPy every time you need to use a function from these libraries is very time consuming. And also it clogs up the space of the code, unnecessarily adds complexity to how you're communicating over your code. So the data science community has developed this shortening of these modules, and basically, as the convention goes, we're importing pandas as PD and importing NumPy as NP. So let's dive right in. Types of messy data and how to clean them. To demonstrate this, I am going to create a new pandas series, which is simply what you guys know as a vector, or a one-dimensional list of items, which may or may contain NA values. Here we're creating a series with 9 items. They're all of type string apart from the 6th item, where the 6th item is a numpy.nan, which is not a number object, which is internally how pandas stores a missing value, right? So we have some series that are mostly filled, but it has a missing value. We want to inspect what we have created. In line 2 of N9, we simply state the name of the object we want to look at, and Jupyter Notebook would immediately show it to us in Out9. Let's look at a different example. One of the common things you need to do when you're cleaning data is you need to access the underlying string data that is present in a data frame. In Pandas, the way you do that is by the string property, and after you have accessed the string property, you can use common Pythonic string functions to operate on these values. For example, in N11, what we're creating here is we're calling the string values of each item in S, and we're telling it to go lowercase. The lower function is well recognized and well used in regular Python, and here we're again using it in the context of pandas. So notice a couple of things. First of all, the data type has been unchanged in objects. Secondly, item number 5, which is a missing value, remains a missing value and no error was thrown. So this string.lower is robust to missing values. In our next example, in N12, we're again calling a slightly different string function, which converts the string into uppercase. This is again a string function that is built into Python, and I'm sure most of you has used this outside of pandas. So that's N12. In int13, we're now using something slightly different. In a normal Python environment, you're going to use the length function on top of the string that you're feeding in. In Pandas, they've implemented this using simply an len function, which you can call. And notice a few things. So first of all, it is not the same way that you're going to use length in normal Python on a string, but it works nonetheless. Number two is the data type has now changed from an object to float64, which makes sense because all of the lengths are floating numbers. And number 5, again, item number 5 is remaining as a missing value and nobody bats an eye. So this shows that this function is also robust to missing values as a type of magic from Pandas. So the common use case of these string functions is to clean up column names. In int20, I'm creating a new data frame where I'm filling it with 5 rows and 2 columns of random numbers using np.random.randn, which is a function that allows us to draw random numbers from a normal distribution. We specify that the columns are somewhat ugly column names with first name and last name, much like what you might find from a dataset that is handed to you randomly. To access the column names, what we need to do is to access the property of the data frame columns, like this. And notice that I have created a call of type around the columns object to show you that this is an index object and not a data frame or a series object. So one of the main use cases is we want to transform first name and last name to something that looks a little bit more like what a programmer would use, or maybe even transform it in a way that allows us to translate this directly to SQL columns. So we can chain string transform calls by calling property str repeatedly. In int17, we're first calling the strip function, which strips away the white space on either side of the column's underlying string. Notice that when we chain up the calls, we need to call string again to give Pandas the second call, which is to turn everything lowercase. At the very end, we call replace call function to replace spaces with underscores. If we set this value back to the property of columns, we can see that the columns of the data frames now look a lot better than the rather unclean data frame column names that we've imported from whatever source we might be dealing with. We can also create a series of lists by applying the split function to the string in the underlying series, as we can see here in int21. We can access its individual elements, like this in int23, where we first split the string underlying string of each value in the series, and then again accessing the string value of each column, we get the first elements of the list. If we set the split function to do expand dot equals to true, which is a keyword argument that allows us to first split a string, turn it into a list, and then turn each item into the list into its individual columns. That allows us to split things like dates and immediately create year, month, date columns. Notice that in replace, the default setting is for replace to detect regular expression patterns. To turn this off, we can use the keyword argument regex equals to false to turn this behavior off. And now you have it. A very brief overview of how we can deal with messy data and clean them. But this is only string data.